Okay, for today's class, what we want to do is combine some of the material that we have learned from last week's presentation and expand upon that a little bit. I have two what we call monohybrid crosses up here, and then we'll put an example of a dihybrid cross up in the near future, if time allows, which I do believe it would. All right, so I'll go ahead and read this problem for you. In certain types of flowers, purple petals are dominant over white petals. Okay, so we have a complete dominant cross where we have one trait is going to express over the recessive trait in this case, because there will be examples where we do what's called codominant crosses and incomplete dominant crosses. But in this case, we're saying that there's one dominant color over another one, so purple over white. If a homozygous purple plant is crossed with a homozygous recessive plant, what is the genotypical and phenotypical results, or ratios, whichever way you want to express that. So the first thing that we want you to do is make up what we call a key. And in this case, you can use whatever variables that you want. Okay, so I'm going to try to use this brown color over here. So we have what's called purple and white. So the dominant trait is purple, so make that capital P. And then a lowercase p, and I'd suggest that you put a line over the top, but again, that's just a personal choice that you may or may not make. So in this case, white. Now, the only way that we can see this white color is if both recessive traits are present. How do we know that? Well, in this problem, we're illustrating that purple petals is dominant over white. So in this cross, even if it's just one allele or one capital P that is in the cross, it will be expressed then. It doesn't matter if there's a capital P and a lowercase p. This is a complete dominant cross. So here is where we would put the vocabulary to work, because it says a homozygous purple plant. Again, from last week, homozygous meaning that both alleles are the same. So in this case, we've got a capital P and a capital P. Okay? Because for one, it's purple, and it says that it's homozygous. So therefore, we can presume, well, it's not that we can presume, we know that both of these alleles and a trait, two alleles make up a trait. If this is homozygous dominant or homozygous purple, both alleles are capital P times or crossing a homozygous recessive plant. Okay, so which one is the recessive trait? We illustrated that in our key. A lowercase p then is white. Okay, so that's what would happen if it's homozygous recessive plant, both alleles, they're going to be two lowercase p's. All right. And then it really doesn't matter then if you, no matter what size you write these, if you put a line over the top, well then you can then presume that that is the lowercase letter. For some of you who may confuse yourself down the road, once you put that line over the top, it will hopefully eliminate any confusion. And we're kind of constrained here for space. I wished I would have maybe put these lines a little closer together, but this is what we've got. Okay. So now let's go ahead and put these in here. And again, it's not like it has to be that big, but I guess with this big whiteboard, I'm just so used to writing so big so that everyone in the back can see that. But now, since we're looking at this on a computer screen, it's probably a little easier to see. All right. So again, what I do on the cross here, whatever's on the left, I put on the left down here. So we got two capital P's. And then whatever's on the right, I put across the top. Two lowercase p's then. Okay. So as we look at this, we see capital P and a lowercase p. And notice that's going to be the same in all four blocks, or all four boxes, whichever way you want to explain that. The last thing we need to do is illustrate the genotype and the phenotype. In the vocabulary terms that it would say probably in your book, which are again due on Friday, I see. We also have our next short evaluation, which is also on Friday, the 30th, is that when we talk about the genotypical ratio, it's the genes that we see in that cross. It's the genetic makeup that you would illustrate here. And notice they're all the same. You have a capital and lowercase p in each box. So there's 4 outcomes that would be possible. So I can go ahead and erase this here because we've already got that taken care of. So in this case, we've got 4, and then just pick one of your boxes, and then if you just want to start in the upper left and just work across and down or down and across, it doesn't make any difference, just as long as you count for all 4 boxes. Okay? And the reason we're putting these 4 here is because they're all the same. Okay? That is the genetic makeup according to this cross. That 100% of the time, you're going to get that type of a genotype. And once you get the genotype or the genotypical ratio, the phenotype is what follows right behind with what you would observe. Also, 100% of the time, what happens when you cross a homozygous dominant purple flower with a homozygous recessive flower, that 100% of the time, you're going to get purple flowers. So in that case, you would write for purple. Now, the reason that's significant is even though that recessive trait is present, it's not being expressed. Okay? This masks over that recessive trait. So our genetic makeup is the alleles or the genes that we see, and then the phenotype is what we would actually observe. You're going to see 100% of the time, in this case there's 4 possible outcomes for purple then. And the reason that's significant, all right, is what would happen if we crossed offspring from, you could say, this F1 generation. Because remember, we had this. This was the parental generation. Okay? So then this cross was the F1 generation. So if we were to do this cross now, and that's something that Mendel had discovered, is does that white trait disappear? I mean, we're crossing these purple flowers with white flowers, and it would appear that any type of white color would disappear, but that is not the case, and this is how we know. Because remember, we said just go ahead and pick any one of them 4 boxes and cross with each other. And again, when you put that line over the top, it's much easier to see what the recessive trait is. So now from that F1 generation, right here, we're going to get the F2 generation. All right, and that can be illustrated by this. Remember, whatever is on the left side of the X, you put on the left-hand side. That's just, again, personal preference. In this case, it doesn't make any difference because they're both the same. And we want to make sure it's not sloppy, and yet I could fail with that. Yeah. Okay, so now we've accounted for both of those. And in this case, these are 2 capital P's, a capital and a lower, capital and a lower, and then 2 lowercase. So then the reason this is significant is this would, what I want to say, fill into your, or apply to your law of independent assortment. I think that is one of your vocab terms as well, is that what Mendel had discovered is that in these crosses, sometimes these just don't totally disappear. Some of these traits, they can come back again, but they have to be expressed just right, okay? So in this case, 25% of the time, or 1 out of 4 possible outcomes, you could get a white color flower again. So the genotype for this is just slightly different. Again, we would just go ahead and erase that. I should have done that earlier. You can just pick one box and then illustrate what's in that box. Okay. Well, we got 2 capital P's here. We got 1. Why did I do that? I'm getting a little ahead of myself. These are capital P's. Okay. We got 2 of a heterozygous sort, and then 1 of this nature. Okay, so 2 capital P's, capital lower, so that's why there's 2 here, and then 1 here where we've got 2 lowercase p's. Okay, so again, that is a genotype because it shows you the alleles and the genetic makeup. Now, the phenotype in this second cross, or what you would actually observe, is remember this dominant trait would mask over this white color. So purple, 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 even though that recessive trait is present, we've got 3 purple and then 1 white. So 25% of the time, you would approximately receive those white color flowers again. All right, this probably would be a lot simpler if this was in person, but we got to roll with the punches here and do the best we can with the information presented and with the tools we've got at hand. Okay, so we can safely erase this now. And maybe you'd have to go back and hit the pause button to slowly catch up. I'm hoping we're putting some time and effort into this because unfortunately, just like you may have observed with physical science, sometimes the content does get to be a little more difficult, and we'll find that out here as well. And it's not meant to say, oh, I want to make this as difficult as we can. No, that's not our goal. Our goal is to make sure that we are prepared for this upon our next academic step. All right. In this case, in mice, brown is dominant over black. Now this is talking about coat color. So in this case, we're taking a little more easier on you. It's a little more convenient just to do the phenotypical ratio, or what you actually would observe. I want to make sure my batteries don't go dead here. Okay, they're still good. So this brown coat color is dominant over black. What's the phenotypical results, or what you actually would observe if a homozygous black mouse is crossed? Ooh, I did that wrong. Homozygous. That's not what I wanted. I wanted this instead. A heterozygous brown mouse is crossed with a black mouse. Okay? And again, this is where you're going to use that vocabulary that has been assigned to you and what we talked about in that presentation that you perhaps watched on Friday. Okay. So again, the first thing to do is make a key. So in this case, this is brown, the dominant trait, lowercase p, lowercase b is going to be black. So now we've got our key here. And remember, brown is dominant over black. So anytime that dominant trait or that capital B is present, or capital B allele is present, it will mask over the recessive trait or black allele. So a heterozygous brown mouse, that's telling you what the alleles are. Heterozygous meaning different. So in this case, we know that it's going to be brown because it tells you that here. So we know the coat color is brown. But if it's heterozygous, remember that's going to be one of each. This would mean it's homozygous brown. And some of you may have read into this far enough to know what your second set of alleles is. Because if capital B is homozygous dominant, well then if it's heterozygous, it has to be one of each. So it's a capital B and a lowercase b. Then it says it's crossed with a black mouse. And the only way that we can have a black mouse, you could say, well, just as long as that recessive trait or recessive allele is present, that maybe results in a black mouse. Well, if we do this, well then we would still have a brown colored mouse. So what that means is the only way that we can have a black coated mouse is if both alleles are recessive or lowercase. Okay? Because again, in a dominant cross, if that capital B allele's in here, it's going to be brown in color. Okay, so let's go ahead and do our cross. Okay. Whatever's on the left, we put on the left side here. Okay, so what are we going to observe? Well, capital B, lowercase b, two lowercase b's, capital B, lowercase b, and then all b's must be what the buzz is all about. Bzzz. Ha, ha. We just told a funny. I'll let you collect yourself after you're done laughing here. All about 2 seconds. Okay, now what we see here, the phenotypical ratio, that dominant allele is present 2 out of the 4 times. So that gives you 50%, or you could say 2. The capital B or capital allele is present, so that's going to result in a brown coat color. And then 2, recessive, recessive. That would result in a black colored mouse. Okay? So 50% of the time, then, we see that with a heterozygous brown colored mouse and a homozygous recessive or a black mouse. Again, it doesn't say homozygous or heterozygous, so when it says black, we know that it's black because the only way that can be possible is if both alleles are recessive. All right. One of the things, as you're watching this, maybe try to think of some questions that you may want to ask. Some of you may have had more exposure to this than others, or some people are perhaps better at deciphering this material than others. It doesn't mean that you can't or won't understand this. Some people will learn this at different rates, and that's okay. Okay. Now we're going to do a dihybrid cross. Ooh, we're giddy with excitement, I can tell. You're not even in here yet. I could say maybe the force is strong with myself. Probably not. Okay. Let's do something like this. So if it's a dihybrid cross, you probably guessed it, it means that there are 2 traits. So I'm going to put the word problem on here and then get it set up, and then hopefully you can fill the chart out, and that's something we'll talk about tomorrow. Again, if you choose not to do this, this could be a little more difficult for you. I'm not saying that it is, but there could be a better chance that it will be. The more time you put into this, the better off you'll be, in our opinion. Okay, so let's go ahead and stick with mice rather than that of dealing with pea plants. So we know that brown is dominant over black for coat color, but we'll just go ahead and continue with that practice. In mice, okay, brown is dominant, not dominant, dominant over brown. I just say the same, I did say the same thing twice. Okay. And a running trait, we could just say, is dominant over waltzing. And what this is, it's a type of neurological disorder that some mice get. They're called Shivera mice. We just call it the waltzing trait. And what it looks like looks just like what it sounds. Look at a mice and it looks like they're just shivering like this, and that's why they call them Shivera mice. We'll see an example of that possibly tomorrow. So what we see happening here, we've got our two traits. Brown is dominant over black. Running is dominant over waltzing. Okay? So what we want to do is, if a homozygous brown, and we'll say, we don't want to have any Shivera mice, so we'll just go ahead and say, and homozygous running mouse is crossed with a black waltzing mouse. Okay, what is the, I just put the P in parentheses, just quicker writing that in there. You know what, that's the phenotypical ratio. Okay, so just like what you do with physical science, you'd want to have a setup to illustrate what you're actually dealing with. So in this case, we know black, or I'm looking at the black marker. We know that brown, so that's the dominant trait, is dominant over black. Okay, and we know we'll just use a capital R for running, which is the normal trait, and then a lowercase r for the waltzing, or Shivera mice. So now we're going to utilize that vocabulary again. Homozygous brown. Okay, so here's our brown trait. It's homozygous, so we got two capital B's. Okay, and homozygous running. Well, here's our running trait, and if it's homozygous, well then it's two capital R's. Okay, then is crossed with a black waltzing mouse. It doesn't say it's homozygous dominant. It doesn't say it's homozygous recessive. It doesn't even say that it's heterozygous. It just says that it's a black waltzing mouse. So I want you to think about, what are the two alleles if it is black coat color? Because rather than just sitting up here and just copying down what it is we're doing, if we're having you think as we do this, I would believe that the better off you'll be. So please trust us that this is in your best interest. Okay, so if it's black, the only way, because if we put a capital B in here, well then that black trait isn't going to be expressed because the brown is dominant over black. So this has to be a lowercase b. So that's the only way we can get that black coat color. Then it says that it's waltzing. It doesn't say it's heterozygous running. It doesn't say it's homozygous running. It doesn't say it's homozygous recessive. It just says waltzing. So here's our trait. The only way it can be the waltzing trait is if two lowercase r's are present. Okay? And one of the things that you'll see that when we do complete this cross, the genetic makeup is going to be the same all the way across. It's just doing an example like this, it's easier to see in this 4x4 that we will be setting up. What do we mean by that? Well, it would go as follows. I want to try to pick a color that you're actually going to be able to see. Maybe try this one. It looks like it shows up, but once you get down towards the bottom, it kind of disappears. Okay, let's just use this black color. I know you're going to be able to see that. Yep. So like I said, this is not a monohybrid cross, it's a dihybrid because it's crossing two traits. And the more neat or better handwriting that you have, chances are the more neat and concise this will be. And I get it, I don't have the best either. So notice we're not trying to do this in a big hurry. So this is where you get to use one of those concepts that you call FOIL. Well, what does that mean? Well, isn't that apply when you are doing factors to where, let's see here, how does that go? X plus 2, and then maybe you're adding, no, you're multiplying them too. X minus 3. Okay. So x plus 2 times x minus 3. When we talk about FOIL, remember the F-O-I-L. It's the first term, so that gives you x squared. Okay? Then it's the outside term, this x all the way out here to minus 3. Okay? Then the inside, and you put them two together, and there is 2x, so that would give you minus x, and then the last one. 2 times the negative 3 gives you negative 6. Okay? So the first term, the two x's. The outside, this outside x, that minus 3, that's the outside term. Inside, this 2, and that x is inside, then the last, the 2 and the 3. When you multiply them, that's where your negative 6 comes from. So the same thing you would apply here. The first term, capital B, capital R. The outside, this B, okay, and that R, because that's on the outside, that's on the outside. The inside, this B and this R. And then the last one, this one and this one. And sometimes it just so happens you get the same results on this side as what you would here. But again, this is for the practice of this process of what we call FOIL. The first term, little b, little r, going across the top here. Little b, little r. Oops. I don't need to put them in there. I need to put them over here. Then the outside, little b, little r. The inside, and then the last. Okay, and that's how you would set that up. And what you would do to finish this is you go like this. So capital B, lowercase b, capital R, little r. You just kind of like an intersection. Wherever these come across in a grid, that's what you would put. We can go down to this one and down to here and say, we're going to do this box. Okay, so for tomorrow, just go ahead and get this filled out, and then we can make more sense of that at that time. We're at about 30 minutes. So again, we'll talk about some of these tomorrow, and if you have any questions, please bring them and we'll address them as time allows and to the best of our abilities. All right, we'll catch up to you next time.